probability that you lose all 5 times. So 1 minus the probability that you lose all 5 times gives us 0.441. So that would be C. Next one, another Venn diagram for us. The security system has 2 units that set off an alarm when motion is being detected. They're either both reliable or one of them is reliable. So they always go off. So either A or B is happening. So either A is happening or B is happening. The alarm's going off. Suppose that for a motion in a certain location, the probability that detector A goes off and detector B does not go off is 0.25. So I'm thinking about my Venn diagram. Let me redraw that without the glare in the way. So, when we think about that Venn diagram, the first thing that gives is the probability that A goes off, but B doesn't. So that would be just the A portion. So that's just 0.25. So that's inside of here, right? Just the A portion. Right? A goes off, but B doesn't, is 0.25. The probability that A does not go off, so that's everything outside of A, is 0.35. But we know that either one's going off. So this is going to be 0. We know A or B will go off, meaning 0.35 will be just the B. Okay? So just the B, right? A doesn't go off, that means that B is definitely going off. And then we want to know what's the probability that B goes off in total. Well, we know that all our whole probability in our sample space has to sum to 1. So we have right now 0.25, the overlap, and 0.35. Well, we know that these 3 things have to sum to 1 because there's 0 on the outside, so this would be 0.4. Right? 0.25 plus 0.4 plus 0.35 will give us 1. So, when asking about what's the probability of B happening, we look at our B circle, it's 0.4 plus 0.35, which gives us 0.75. Good. That one I would say is kind of tricky to set up, but pretty simple to understand. Right? Either one's going off. So probably just B goes off would be the probability, or that B is going off would be the probability that A is not going off plus the overlap, right, if both of them are going off. This one's a nice little problem here. You guys are playing a tennis match against your friends. You believe that the outcomes are independent for any given match, so the probability of point C of winning. So you have a 60% chance of winning no matter what against your friend. Says, what's the probability that you win the next 2 matches? Well, we've got 0.6 times 0.6, which is 0.36. Okay? So the probability of a win and a win, right? The events are independent. We can multiply them. You can think about it on your tree diagram, right? Win, lose, so 0.6, 0.4. Again, win, lose, 0.6, 0.4. Well, we got the win-win branch. We'll do 0.6 times 0.6, right? A win times a win. Next one. I find that this is helpful to draw a tree diagram for. So maybe go ahead and attempt that first. And check your answers with me here. So, first thing, we have this coyote, right? And he's pursuing the roadrunner. The roadrunner chooses his route randomly, such there's a probability of 0.8 he'll take the high road and 0.2 that he takes the low road. We're going to start with our branch.